Sir. Okay. This is part 3, part 2. Okay, in the previous lecture, we have studied what is a linked list and how to create the linked list that we will see today. Okay, now what is a linked list? It is a okay. What is a linked list? You will have a structure, and each structure will have a link to the next structure. Okay, that is how a linked list is created. That is why it is called a self-referential structure, because a structure is pointing to the similar type of structure. It is pointing to identical structure, or you can say identical node. In linked list, every structure body will be known as a node. Okay, so this is one node, second node, and third node. The type of list is called a linked list because it is a list in which order elements is given by the link from one item to the next item. Okay. Each structure element in linked list is referred to as a node, as I told you. Now, linked list node, you will have in every structure now two parts. One is the data part, one is the pointer part. In data part, you will have the structure variables like item name, item number. Okay, everything you will be having. Okay, over here, name, student roll number, ID number, everything. Okay, and one here you will have a stop pointer, that is a next pointer. For simplicity, the item is of integer number only. Could be any complex data. Item may contain more than one number with different data type. The essential structure member is a pointer of the type tag name. So this is the pointer. Okay. Now the structure tag name is node, and we are creating a similar structured node pointer is here. Okay, that is a next. As I told you, for simplicity, here they have taken only one value, that is item. But in your structure, if you are creating a structure of student, then you can have name of the student, roll number, okay, marks, address, contact details, and then you will have a pointer. Okay. So you can have multiple data items, but to understand the linked list and keep it simple, we will take only one value. Any one value you can take. If it is working, then you can add more number of data. There is no problem. Okay. So for simplicity, we will consider only one list of data. See the example of structure node, or you can say one node in your linked list can be like this: structure node, item, and pointer. Another structure linked list will have ID, name, age, and the pointer. See, the pointer here is struct node. So struct node pointer next. Here it is struct linked list. So it's a struct linked list pointer. So they are individual linked list example. Okay, this is 1, this is 2, and this is 3. So in generalize, you can write like struct tag name. Here's a list of items, means the data part, and the second will be the pointer. Second field is the pointer to the next node. Okay. Now, linked list example. Okay, just go through this once. Now, the linked list example, structure linked list. One is the item part, one is the pointer. Okay. Now, suppose you want to create 3 node of the same structure. That is nothing but a 3 variable. Okay. Suppose I have structure student, then I can create 3 variables S1, S2, S3. These are the 3 structure variable. If it is a structure student instead of list, if it is a structure student, then you have 3 structure variables S1, S2, S3. Similarly, it is a structure linked list. So we are creating struct linked list 1, 2, and 3 structure variables. Now you know that in every structured variable you have one item and one next point. So item is having some number value. So suppose node 1 item is 10. Now, as we have told that one node will have or will point to the next node. So what is the next pointer value in the first node? So node 1 dot next is the address or the pointer to the next node. So for example, whenever you create node 1, node 2, node 3, they will have some memory allocation, they will have some address. Assume the address of node 1 is 5000. Address of node 2 is 7008. Okay, and address of node 3, that is for example 8500. Sorry, here it is given 8000, so we will take it. Fine. Now, the first structure should point to the second node. So, first structure, that is a node 1, the value of next pointer is equal to 7008. So, the meaning is this pointer is pointing to the second node and the second pointer, the pointer of second node will point to the third node. So address of third node is 8000. So we will write here node 2 dot next is equal to address of node 3, that is 8000. So you can say 2 is pointing to node 3, node 2 is pointing to node 3, and the item value of node 2 is node 2 dot item 20. So first is 10 item value 20, address of this is 7008, address of this is 8000. All of you getting this? Yes or no? Please tell me.
Yes, sir. Yes, sir.
Yes, any confusion? Anyone?
No, sir.
Am I audible? Am I audible? The screen is visible, everything is fine?
Yes, sir.
Okay. Now, the linked list continue. In array, the last item is always size minus 1. We know that if I create the integer array of A10, okay, if I declare integer A10, we have already discussed this, the last element would be A9, that is the size minus 1. We know the index will be minus 1 because index starting from 0, A0 to A9, okay. So the last index will be size minus 1. Similarly, your list is not infinite. The list uh, does not go on forever. There must be the end of list. This is essential for processing the list. We must therefore indicate the end of the linked list. So we will write null in the next field for the last node. So if this is going to be the last node, that means what? It is not pointing to any next node. This is the last node. Beyond this, there is no nodes available. So this pointer is not pointing to any valid node. That means we will make it 0 or we will make it null. The meaning of this is, it says, yes, this is the last node. Beyond this node, there is nothing. Okay, so this will indicate the end of the linked list. So you can write node2.next equal to null or node2.next equal to 0. 0 or null, both values are valid. Okay. Now linked list advantage one more time, and we are keep on repeating this. It is a dynamic data structure, so it can grow and shrink in size during the program execution. You can increase the size, you can increase the number of node, you can decrease the number of node. You can allocate memory for node using malloc-calloc. Okay, and you can also free the memory. It does not waste the memory. It is not necessary to specify the number of node to be used in the list prior, so it will not waste the memory. And memory for a list node can be allotted or can be freed at any point of time. Same topics, okay, which were discussed here, memory allocation and free. The linked list provides the flexibility in allowing item to be rearranged efficiently. We will see how we can rearrange the item just in the next topic. I will not discuss this right now. Limitation. Traversing in a list is little bit cumbersome and time consuming. Because if someone says that you travel in the list or I want to read the value of third node, okay, so you do not have the address of third node directly available. You just have the beginning of the list. From first node you can go to the second node. From second node you can go to the third node, because the second node next value is giving the value of third node. So by sequentially traveling, you can get the third node. Directly third node is not available. Okay. So that is little cumbersome. In array it is directly available. I can easily write A3, that is a fourth element, or I can write PT pointer plus 3. Okay, like this. Then I can easily access the fourth element in array. It is simple in array, but it is somewhat difficult in linked list. Linked list will use more storage than array because it is having one additional link field. Okay, if you just creating, compared to array, if you just creating array of structures, if you write, then in array of structure you will have only data part, that is student name, roll number, address, contact detail, everything. But you will not have this link, okay, in array. This is not needed in array. So in linked list it is extra added. Okay, that's why it will occupy some more memory compared to array. Now here, see, in this topic, linked list provides a flexibility in allowing items to be rearranged. Okay, it is quite easy to rearrange the item. Suppose you have item 1, 2 and 3 in a linked list like this, and you want to insert a new node, that is suppose X. this X node you want to insert between 1 and 2, then simply you can do what? The next pointer of the node 1 should point to X, and the next pointer of the X should point to the node number 2. So this, by doing just this two alteration of the pointer, you can insert a node in the list. Okay, why? Well, it is, if it is in array, then array, if you want to insert something in between, suppose the value is 1 is here, 2 is here, 3 is here, and you want to insert the X in between 1 and 2, then what you have to do? 1 here, X here, shift your 2 here, shift your 3 here. So you have to shift this 2 here, shift this 3 here. So this shifting is what you need to do in case of array. If you want to insert some value in between, so you have to shift n number of values which are beyond this. Okay, but it is quite easy in linked list. Just change these pointers by altering these two pointers. See, your node is added. Everyone can understand this. This is most important. Yes or no?
Yes, sir.
Okay. So compared with array, if in array you have 1, 2, 3 and you want to insert X here, so you 1 is as it is, but you place X here, 2 you shift up by 1 position, 3 you shift up by 1 position, and if suppose n number of nodes are beyond this, then all you have to shift. Okay, like this. X will be here, 2 is here, 3 is here. But in linked list, graphically you can see, okay, only this two, by changing this two pointer value, you can simply add a node in between. Okay, similarly you can delete a node. Okay, now from array, if you want to delete this 2, then what happens? Let us, you want to delete this X, then what you have to do? 1 is here, bring this 2 down, bring this 2 here down, bring this 3 here down, so 2 and 3. You have to shift n number of values one position down. Okay, so again you have to perform the shifting. But in linked list, if you want to remove some item from the list, suppose I want to remove this. This is 1, this is 2, and this is 3. I want to remove this item. Simply, you have to make this next pointer point to the third node. It is no more pointing to the second node, but it is pointing to the third node. So this is automatically gone, because linked list is always traversed by next pointer. 1 will give you the address of 2, 2 will give you the address of 3, 3 will give you the address of 4. But if 1 is giving the address of directly 3, so definitely your 2 is gone, 2 is deleted. It is no more available in the linked list. So this way you can delete a node. Yes, everyone. Are you able to understand? Yes or no? Any confusion? Tell me if you have any questions. Yes? Clear?
Yes, sir.
Okay. Then you have type of linked list, linear linked list, that is the simplest linked list. Circular linked list you can have. 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to 1 back. Okay, 3 is pointing to 1. So it is a circular. You can have two-way. Two-way linked list means you will have 1 is pointing to 2, 2 is pointing to 1, that is a forward link. Or you can say this is a backward link and this is a forward link. From 1 to 2, 2 to 3. If 2 to 3 is a forward link is this, then reverse link is 2 to 1. Address of 1 is like this. So 2 can also have the address of 1, 2 can also have the address of 3. That means you need 2 pointers. Till now we have only 1 pointer, that is a next. Here you have only 1 pointer next, Similarly, we will add one more pointer, that is back. Okay, next or back. Next and back. So this will point to the next node, this will point to the back node. Okay. So this way you will have a two-way linear linked list, and then you will have a two-way circular. So this last will point to the first will point to the last. So this way you can have a two-way circular. So four types of linked list: linear, circular, two-way, linear, and two-way circular. We will study only this in our syllabus. Okay, linear linked list. Linear single linked list, we will study only this. Now we are coming to the topic how to create the linked list. Till now we have studied the theory part of the linked list and we understand the concept, how it is working. Now we are going to start creating the linked list. Okay. So this is your structure linked list. It will have item, it will have next. Now in your program, whenever now we are going to create a pointer next with this structure, we don't want to always write struct linked list next, struct linked list first, struct linked list something else. Instead of that, we will use a type def struct linked list into node. So instead of writing struct linked list node, struct linked list, we will write only node. Node is a new name given to the struct linked list. That's why we are using the type name. You know type name, use of type name. Okay, type name, integer, marks. So now your marks is a new name of the integer. So using marks you can create variables. Similarly using node, now we will create the variables because node is a new name of struct linked list. Okay. In linked list we do not have how many number of nodes are going to be there in our linked list. That's why of course we are using the DM. આપણને ખબર જ નથી કે લિંક લિસ્ટમાં કેટલા નોડ હશે. ઓકે, જો એ ખબર હોય તો આપણે એરે યુઝ કરતા, શું કરવા, ડીએમએ યુઝ કરતા, બરાબર. So we don't know how many number of nodes going to be there in our linked list. So we will start with one node and our linked list will keep on growing as the more number of nodes are added. So you can take the same example which we have discussed yesterday, that vaccine registration. Okay, you start registering for vaccine from the first node, that is the first person. In our case, first node is first person. We do not know how many number of people going to register for vaccine today. So first person registered, your first node in the linked list created. When the second person comes, second node is created. When the third person comes, third node is created, and so on. Your linked list will keep on growing. Understand? Any doubt? Okay, is it okay?
Yes, sir.
Okay. Usually we create a linked list with initially having one node, as I told you this. Just like the string character will have a null. Okay, that is only one byte. Create a pointer node, say head. So we are creating one pointer head. So we will write like this, node pointer head. What is the meaning of node pointer head? It is a struct linked list head, because node is a name of struct linked list head. So we are creating head pointer of struct linked list, because node is nothing but node is a new name for the struct linked list, because we have used a type def. Okay. Now create the storage. You just created one pointer. You created a pointer, but where is the memory? Where is the memory? memory is not yet allocated. So allocate the memory for one structure variable using malloc size of node and the typecast node pointer. Here what we will write, struct linked list pointer, malloc size of struct linked list. Instead of struct linked list, we are writing node. Size of node depends on how many elements are there. Okay, right now you have two elements, integer 2 byte, pointer 2 byte, so total 4 byte. Based on the item, based on the data available in your structure, memory is allocated. Suppose one structure variable is having 50 byte, so this will allocate 50 byte. Here it is 4 byte, so this will allocate 4 byte. So memory for one structure is allocated and the head is assigned to head. So head is pointing to this memory. So first of all, we declare one pointer, then we allocate a memory and we assigned it here. The same thing we have done yesterday in our program where I have done like this PTR. PTR is equal to malloc. Okay. So here our PTR was the pointer. In yesterday's example that we have seen the practical, okay. PTR is pointing to this memory location. Same way here is a head. This node may be the end node if the link is empty. If you have only one node, then this can be the last node. Now ask user to input a value. After doing this, our third step is step 1 pointer, step 2 memory, step 3 you will ask user that -99 to indicate the end of item, you have to enter -99 to indicate the end of list. So enter the item value. So this item value, user will enter a valid number like 1, 2, 3, 4, 5, 6, 7, whatever number they want to enter. Suppose here the students are going to enter their roll numbers. So roll number 1, roll number 2, roll number 3, they will enter. If it is the end of registration, then we will enter -999. Okay. Yesterday, in the example, we have taken the 1 and 0 as our choice. Enter 1 if you want to register more student. Enter 0 if you want to stop. If you can recall, yes or no? So it is having the similarity with the yesterday's example where we allocate the memory one by one. And based on the choice, our do while loop will continue. If user says 0, I do not want to enter any further registration, then program will terminate. If user enters, we will, after printing the message, user will enter the value so that we will scan. Okay, now head memory is allocated and head is pointing to this memory. So if we are scanning the value of item, so how we can scan? Head arrow item. So that is what is written here, head arrow item. Scanf %d head arrow item. So we are entering suppose 20. So we are entering 20. For the item value other than -999 means user has not entered -999. So maybe the next registration, this registration is done. Now we have to allocate memory for the next registration. Okay. So we need to create a new memory for the end node. As the storage creating using step 2 is now utilized by the list item. So this storage is for 20 and this can be the next node. Okay. If head arrow item is not equal to -999, we allocate one more memory is this. But whatever pointer written by this memory, where we will save? We will save this into head arrow next. Head arrow next is this is equal to new memory. So head arrow next is equal to a new memory. Similarly, a node malloc size of node. So see, first of all, we allocated memory for head. So head malloc is this. Then we scan the value here 20. Then we allocate one more memory into head arrow next. So head arrow next equal to this address. So it is explained here. Understood everyone? Yes or no? Step 1 to step 5. Is this clear?
Yes, sir.
Yes, sir.
Okay. Again, the steps are written 1, 2, 3, 4, 5 steps written. Now we need to repeat 3 to 5 for other inputs. Okay. Now you know you will repeat in a loop. Okay, you will repeat in the loop if you are entering one more values. Suppose now after allocating memory, head arrow next. Now you have to scan the value for this item. How you can access this item? It is head arrow next arrow item. Okay, but what is written in this scanf? In this scanf it is written head arrow item. So if we write only the same statement in the loop, if we write the same statement, then it will overwrite this 20. If I enter the second value, suppose 10, and I keep only the same statement, it will save 10 here because it is head arrow item. Instead of that, what should we do? We should do head arrow next arrow item. Are you getting this? Yes or no?
Yes, sir.
If we have to scan the value of this item, we cannot use this statement. Statement number 4, shown in step number 4. If we do that, then where it will scan head arrow item, where it will scan head is here, head arrow item, it will scan this value and it will, suppose I enter 10, it will overwrite 10 here. It is not scanning this value. Instead of that, we have to do head arrow next arrow item, means head arrow next arrow item. તો આપણે આ કરવું પડે. Okay. So this we cannot do, otherwise it will 20 is already stored and it will overwrite. Okay. So that is why one more thing is needed. We always do I++, increasing further. So what I can do, I can increase my head if I want to keep the same statement here. After doing this, I can increase my head. Head is equal to head arrow next. Means head is equal to head arrow next. So head is pointing here now. And this head link is broken. Now head is here. Now if you scan %d head arrow item, then definitely head arrow item, it will scan this. Suppose I enter 30. Now it will perfectly work. Yes or no? This is needed in our loop I++. We have to also increase the pointer. Okay. You can take the, if you are unable to understand, please see this. If this is a array, okay, integer array, and pointer p is an integer pointer, and I am scanning like this. Why we are writing this? Scanf %d and we write here p plus I. Why we write this? P plus I. Why we increase the pointer? Because p, if I scan the value in p, then it will scan the first value. If I want to scan the second value, I have to do p plus 1. So it will scan the second value. P is here, but p plus 1 is here. P plus 2 is here. P plus 3 is here. All of you getting this? Yes or no? Following? Are you with me?
Yes, sir.
Barabar? So we have to also increase the pointer head so that head arrow item will point to this. Now if I scan head arrow item, then it will scan 30 here. Okay. So, and we will allocate one more memory because this is not a minus 999. So it is not the last node. There may be some more nodes to be entered. So we will allocate one more memory, and that memory will be stored in the head arrow next equal to malloc. So head arrow next, head is here, so head arrow next is this. Head arrow next equal to malloc. So this is the fourth block, fourth node generated. Okay, sorry, third node generated. And the memory is saved in the head arrow next. So this is pointing to the third node. Okay, and the step will again repeat. 3, 4, 5 will repeat. Again it will print that enter minus 999 at the end. You enter the item value. If you want to stop, minus 999. If user enters, suppose 50. Okay, then if I scan head arrow next, where it will scan? Head is here. Head arrow next, head arrow item, it will scan here. But now it will not do because we have inserted a increment step. Head is equal to head arrow next. This will be the part of loop. This will be the part of loop. So now head is equal to head arrow next. So head is here. Now this link is broken and your head is here. So head arrow item, it will scan the item value here, that is 50. And head arrow next is equal to new node. So here you have a new node. Now if you enter, after doing head is equal to head arrow, now if you enter minus 999, so the item value is minus 999, and if the item value is minus 999, this loop will break. Now we will not continue in this loop. If it is minus 999, our head arrow next will be 0. And we will end the creating process of linked list. All of you getting this? Any doubt, any confusion? Yes? Hello?
Yes, sir.
Okay.
Yes, sir.
So finally, at the end, your head will be here. At this point is your head. આ point પર તમારો head હશે. Okay? But you lost the link to the beginning of the linked list. This pointer has lost. So you forgot from where you started the linked list. તમે head ને increase કરતા કરતા તો આવી ગયા, પણ હવે તમારું beginning ક્યાં હતું linked list નું એ ગાયબ થઈ ગયું. You lost this. That's why linked list is little bit tricky because you are dealing with pointers. Okay. Linked list માં તમે pointer જોડે રમી રહ્યા છો કેવા, you are playing with pointers. That's why it is a bit difficult to understand. Okay. So you reach here, but now your head is lost. So yes, how we can preserve the head? Can anyone give the answer? યસ, આપણો હેડ લોસ થઈ ગયો તો આપણે હેડને પ્રિઝર્વ કેવી રીતે કરી શકીએ? Yes, try. You can give the answer. It's not difficult. Am I audible? Yes.
Yes, sir.
તો હેડને આપણે પ્રિઝર્વ કેવી રીતે કરી શકીએ? સિમ્પલ, ગઈકાલે
Or by
એક્ઝામ્પલ.
using another pointer.
યસ, સિમ્પલ. એમાં કઈ ડિફિકલ્ટ એટલું છે નહીં. મેં ગઈકાલે તમને આ બતાવ્યું હતું કે તમારે કશું લોસ થઈ જતું હોય તો એને તમારે પ્રિઝર્વ કરવું હોય તો બીજો વેરિયેબલ લઈ લો. તો બીજો એક વેરિયેબલ બનાવી લો, સ્ટાર્ટ. ને સ્ટાર્ટ ઇક્વલ ટુ હેડ. એટલે અહીંયા સ્ટાર્ટ એક બીજો પોઈન્ટર આવી ગયો અને એ સ્ટાર્ટ છે અને સ્ટાર્ટ અહીંયા પોઈન્ટ કરે. હવે ભલે ને હેડ બદલાઈ ગયો, આઈ કેન ઇઝીલી રિટ્રાઈવ ધ વેલ્યુ ફ્રોમ ધ સ્ટાર્ટ વેરિયેબલ. સ્ટાર્ટ પોઈન્ટરથી મને આ મળી જશે, બિગિનિંગ ઓફ લિંક લિસ્ટ મળી જશે. ઓકે, સિમ્પલ. અને બિગિનિંગ ઓફ લિંક લિસ્ટ મળી જાય તો હું આખું લિંક લિસ્ટ એક્સેસ કરી છું. કઈ રીતે? સ્ટાર્ટ એરો આઇટમ, સ્ટાર્ટ એરો નેક્સ્ટ એરો આઇટમ, સ્ટાર્ટ એરો નેક્સ્ટ એરો આઇટમ, સ્ટાર્ટ એરો નેક્સ્ટ એરો નેક્સ્ટ એરો આઇટમ. I can easily get my complete linked list if I get the start. And how we will preserve it? We will save head in start. So that is what everything explained in this slides. એટલા માટે they have taken first. Okay. I said start. The name here is first. So we lost this લિંક. આપણે આ લિંક લોસ કરી દીધી અને છેલ્લે ક્યાં હશે? હેડ અહીંયા હશે. એટલા માટે આપણે શું કરીએ? ફર્સ્ટ ઇક્વલ ટુ હેડ. As I told you, start equal to head instead of the name start. Here the name is first. First equal to head. So first you take one more variable and you write at the beginning first equal to head. So now complete link you can get, complete list you can get from the first pointer, even though you have lost your head. Okay. So this is the complete program. Node, memory for first node, first equal to head, print the message, then scan the value. If the value is minus triple line, create one more memory, increase the head equal to head arrow next, and repeat the loop. Scan the value. If it is not minus triple line, allocate memory, increase the head, again repeat the loop. Okay. Now if user enters here minus triple line, then this if is false. When this if is false, you get in else. And you just make it a null and your loop will terminate because it is a go to loop. So here there is no go to, so your loop will terminate. Instead of go to, you can use while or do while. So it is an alternate of go to. Someone says I don't want to use go to, I can use while loop or do while loop. So in else, it is an infinite loop. In else, to terminate the loop, we can use break. In else, we can use break. Yes, look at this. If any confusion, you can ask. Yes, everyone, creating a linked list is clear?
Yes, sir.
Yes, sir. So let us create and let us I'll show you how to create a linked list. You can okay, I think our time is running. 2:50 is end time. Lecture ending time is 2:50. 3,
245, sir.
245, and it's 254. So should I continue, or we can see the, because I have to copy the complete code, run, and then I can show you. So what you can do is, you can copy this statement if you want. You can copy this statement. You don't have in this PDF. So you can just take the screenshot of this. Just take the screenshot of this first part. Take the screenshot. Taken. And the second part is this void main. Take the screenshot of both. You can run the code. You can create the linked list. But અહીંયા તમારો પ્રોગ્રામ કમ્પ્લીટ થઈ જશે તો લિંક લિસ્ટ સ્કેન થયું અને પ્રોગ્રામ પૂરો થયો. So you won't be able to see your linked list. હજુ તમને તમારું linked list દેખાશે નહીં જ્યાં સુધી તમે પ્રિન્ટ ના કરો. ઓકે, લાઈક તમે એરે સ્કેન કરો, બરાબર? પ્રોગ્રામમાં એરે સ્કેન કરો અને પ્રોગ્રામ ટર્મિનેટ થઈ જાય તો તમને આઉટપુટ શું દેખાય? કશું નહીં. તમે જે એરેની વેલ્યુ એન્ટર કરી એ તમને દેખાશે તો નહીં. You won't be able to see the array value unless you print the array. So that part is remaining. How we can print the linked list is very simple. You have to take the first pointer and head pointer. Print head, printf head percentage the head arrow item. Print this, and then you increase head is equal to head arrow next. 2 step. Okay, one is print, another is print head arrow item and head equal to head arrow next. You do this, you repeat this until you reach at the null. Only this you have to do in printing operation. Okay, for printing a array, what we are doing? We are writing like this: for I equal to 0, I less than 10, I plus plus. So my termination condition is what? I less than 10, because I know there are total 10 elements. Here my termination condition is what? Head arrow item. We have 2 conditions. Okay, head arrow item, if it is minus 999, it can be your termination condition, or head arrow next equal to null. You can use any of the condition. Okay, you can use the condition head arrow item equal to minus 999, or you can use the condition head arrow next equal to null. This or this you can use, and you can print the complete linked list. So by copying this code, you can create the linked list, and by doing this, you can print the linked list. Try to do. If you are not able to, don't worry. We will repeat the complete thing in the next lecture. Okay? Yes, thank you.